Maths chapter 8, Algebraic expressions and identities. Addition and subtraction of algebraic expressions. Let us first try to understand what are algebraic expressions. These are examples of such expressions. X plus 3. This is combination of a variable and constant. Is called as a algebraic expression. So all these are examples of algebraic expressions. In earlier classes, we have also learnt how to add and subtract algebraic expressions. For example, let us add these algebraic expressions. 7x square minus 4x plus 5 and 9x minus 10. Here we write this 9x below its like term, and 5 is constant and 10 is also constant. No like term for 7x square, so we can add 7x square with 0x square. So our answer will be 7x square. Now we have minus 4 and no sign is here, means this is plus 9. This plus minus becomes 0, this plus minus becomes 0, this plus minus becomes 0. So this becomes 0 and we left with plus 5. So answer is plus 5x. Similarly, we have plus 5 and minus 10. The equal number of plus and minus, they add up to 0. So this add up to 0 or they cancel each other. So we left with negative and they are 5 in number. So answer is minus 5. Here we have 3 algebraic expressions. Let us first add 2 of them. Here we are going to write the terms below their like term. 4yz is like to 5yz. So it will be below that term. 9zx is like to 3zx. It has no like term. Minus 4y has no like term. So that will be, or nothing will be there in first expression, or we can write that as plus 0y. Now let us add this. 7xy plus 0xy is 7xy. No sign is here, means plus. Plus 5 plus 4 is plus 9yz. Minus 3 plus 9. Positive signs are more in number. And 9 minus 3 is 6. Minus 4y. Now let us write terms of this third expression. Minus 3zx. Minus 3zx will be here. xz is same as zx. Plus 5x. No like term. And minus 2xy. Seven xy minus 2xy is plus 5xy because positive are more in number. Nothing is there to add with 9yz, so that remains as it is. Plus minus, so let us subtract. Positive number is greater, so answer will be positive, and this is 3zx or 3xz. No like terms for minus 4 and plus 5x. So this is how we can add or subtract the algebraic expressions. The sum of the expression is 5xy plus 9yz plus 3zx plus 5x minus 4y. Note here that a minus 4y in the second expression and 5x in the third expression are carried over as they are, since they have no like terms in the other expressions. Similarly, we can subtract, but before we subtract, we have to change the signs of the terms in second expression. We have to subtract this expression from this one. So we write this one first. 5x square, it will be here below 7x square, minus 4y square is below 8y square, plus 6y below its like term, and minus 3 no like term, so we write it at the end. Now we have to subtract. So change this signs. This is positive 7. When we write subtract 5 from 7, we write it like this. Here we change the sign of this plus 5. Similarly, we are going to change the signs. No sign is here means it is positive. So let us make it negative. No sign is here. No term is here. This becomes positive, this negative, and this positive. You have to change. If it is positive, make it negative. If it is negative, make it positive. Now 7x square minus 5x square is 2x square. No like term to this, so we have to carry it. Now consider this new sign. Plus 8 plus 4, that is plus 12y square. No like term for this term. Ignore this sign. Minus 3, negative 3 and negative 6. So in all they become minus 9y and plus 3. This is how we subtract the given polynomials or algebraic expression. 2x square minus 4xy plus 12y square plus 5x plus 12y square plus 5x minus 9y plus 3. Right. Now we can add and subtract the expressions in exercise 8.1. Multiplication of algebraic expressions. This is the introduction. As we multiply 4 into 9, in all they are in this pattern. 4 rows, and in each row there are 9 dots. So in all they are 36. Similar to this, we are going to multiply variables also. Multiplying a monomial by monomial. Before we start multiplying these monomials, we have to consider product of variables and product of constant. Now for that we have laws of exponents. A raised to m into a raised to n is equal to a raised to m plus n. Also a raised to m upon a raised to n is equal to a raised to m minus n. Now for multiplication we are going to consider this law. Where we are going to use this law? If I have 5x multiplied by 3x square, this is our problem or example. Here we are going to multiply constants and variables separately. 5 into 3 is 15. Now this x into x raised to 2, their multiplication will be using this laws of exponents. As there is no power, we consider this as 1, and this answer will be x raised to 1 plus 2 m plus n. So here we have x raised to 3. Multiplying two monomials. Which are two monomials? This is 4 into 3x. There is no variable for multiplication, but 4 into 3, this constant multiplication is 12, and this one is x. Now why we write this as x? We have this 4. that can be also written as 4 into x raised to 0, because this x raised to 0 is 1. Now this 4 into 3 is 12 and x raised to 0 plus 1 is 1. So our answer is 12x. We don't need to write this as x raised to 0. This is just for understanding purpose. X into 3 into y, x into 3 into y. The variables are different and there is no other constant. So our answer is 3xy. Now 5x into minus 3y, 5x into minus 3y. Product of constants is 5 into minus 3. In product of two numbers, if the signs are different, then the answer is negative. Positive into a negative term, answer is negative. Negative into negative term, answer is positive. And positive number into positive number, answer is positive. So whenever in product of two numbers, if the signs are different, answer is negative. Here we have 5 into minus 3, so this is minus 15. These are not like variables, so we can write it as minus 15 x into y. Multiplying 3 or more monomials. Let us try to multiply this. 4xy plus 5x square y square, not plus, it is product, so multiplication. Now let us multiply these constants. 4 into 5 is 20, 20 into 6 is 120. Then what we have, this x into this x square, so that is actually, this power is 1, 1 plus 2 plus 3, because we have 3 terms of x with different powers. Now what are powers of y? 1, 2 and 3. So y can be also written as y raised to 1 plus 2 plus 3. So our answer is 120 x raised to 6 and y raised to 6. So by using these concepts we can complete exercise 8.2.